Hey everyone, and welcome back to On the Spot STEM. Today, we're going to be doing day 3 of the 30-day LeetCode challenge, Maximum Subarray. Find the contiguous subarray containing at least one number, which has the largest sum, and return its sum. So in the example array, the output would be 6 because the largest subarray would sum to 6. And we're asked to do this in O of n. So to solve this problem, we're going to be using Kadane's algorithm. So how you update the current and max values is, you start from the first element and set that as equal to the max and set the current. So after that, if the current sum is less than 0, you set it back equal to 0. And then after that, you go on to the next element. You add that to the current sum and you check if that's greater than the max. And if it is, then you set the max to the other value. If the current sum is less than 0, then you set it equal to 0 again, and you rinse and repeat until you get to the end of the array. So let's walk you through the algorithm one by one, and we can see what the maximum sum is. So we start with the number 2, and we set that equal to max. So max equals -2, and our current is also equal to -2. Since the current is less than 0, we reset the current as equal to 0, and then we move on. The next element is 1, so we add 1 to the current. And after that, we see if we need to update the max. And we do, since 1 is greater than -2. So then we set max equal to 1. Next, we move on to the next element, -3. So we add -3 to our current, and that becomes -2. And then we check if max is greater than current, which it is not. So then after that, we see if current is less than 0, which it indeed is, so we set current back equal to 0. Then we move on to the next element. The next element is 4. So we add 4 to current, and 4 is greater than the max, so we update max. And current is not less than 0, so we move on. Then we move on to -1, so we update current, and we do not need to update max, and we do not need to change current to 0. And after that, we update current again, plus 2 is 5, and then we also need to update max because 5 is greater than 4. And then we move on to 1, which gives us 6, and we need to update max because 6 is greater than 5. Now we update current again. Current is 6 minus 5, so it's 1 now, and that's not greater than max. And then we add 4, which means current is 5, which is not greater than max. So then we return max, which is equal to 6, which is indeed the answer. So how does this algorithm work? Why do we need to set the current sum equal to 0 every time the sum becomes less than 0? Well, if you look at an example right here, the 4, -1, 2, 1, the current sum before that was a negative number, 1 and -3. So if you include the entire subarray from 1 to 1, you'll end up with the sum of this maximum subarray plus the negative number before. And we know that's not optimal because we can just not include the negative number and we'll end up with a larger sum. So now that we've shown that this algorithm works, let's see what this looks like in code. So over here, I have my code for maximum subarray. We first start by setting max equals num0, just in case none of the numbers are greater than or equal to 0, and we set current equal to 0. And then we run through our algorithm. So we add the next element of the array to current, then we update max, and then we update current if necessary. And at the very end, we will return max. So let's submit this. And as you can see, it beats 100% of the Java submissions. Thank you all for watching. Hopefully you learned something new, and if you enjoyed, be sure to like and subscribe. And stay tuned for further videos.